Welcome to the Deep Dive, the place where we take the source material you provided and turn it into instant, thorough expertise.
Today, we are definitely focusing on the factory floor.
Yeah, but not the smoky, rigid one from the last century. We're looking at how industrial automation, especially these smart, flexible robots, is completely changing the game.
hmm And our sources for this deep dive, they made one thing clear right away. Modern robotics is really a story of versatility and integration. It's so much more than just those big caged machines.
So our mission here is to really synthesize that data, pull out the foundational ideas, and give you what you need to know about this new era of automation.
Exactly.
Okay, let's unpack this then. When we're talking about industrial automation today, it feels like we're really talking about solutions designed to boost three very specific things: productivity, safety, and efficiency.
Right. But it's not one size fits all. The sources highlight two pretty powerful categories making this happen.
You've got your traditional high-speed industrial robots, your IRs, and then the newer, super flexible collaborative robots, the cobots.
And that distinction is, well, it's crucial. They're both versatile, sure, but they operate in completely different ways.
How so?
Well, the traditional IR is all about power and speed, massive payloads. It's a workhorse that, for safety reasons, has to be kept separate from people, behind heavy guards,
Right. The cage.
the cage. But the cobot, that's the adaptive tool. It's built for efficiency in shared spaces.
And those three drivers we mentioned, productivity, safety, efficiency, that's the why, right? That's why companies are investing so much in these systems.
It is. And if you ask what the most immediate benefit is, it's consistency.
Consistency.
Yeah, because that one thing elevates efficiency and productivity at the same time. A robot doesn't get tired, it doesn't need a coffee break, and it performs a task with, precision measured in microns, 204/7.
So you're eliminating that human variability that can lead to wasted material or slower production times.
Exactly. But it's not just about speed.
No, the sources really hammered home the safety angle, which might actually surprise some people who only see the dollar signs from productivity. How does automation boost safety beyond just, putting a fence between a person and a machine?
It's the subtle stuff. It's the cumulative damage we avoid. These systems are designed from the ground up to handle jobs that cause long-term chronic injuries in people.
So we're talking about things that are repetitive or need extreme precision or are just ergonomically a nightmare.
Precisely. Think about lifting heavy parts all day, or making the same tiny sealing motion thousands of times, or bending over a hot press. When a robot takes that on, you are directly saving an operator from carpal tunnel, from repetitive strain, from chronic back pain.
So it completely shifts the human's role. You go from being a component in the assembly line to being the supervisor, the programmer, the person who maintains the system.
A much higher value role.
And a much safer one.
Absolutely. You're trading tasks that cause physical and mental fatigue for jobs that need critical thinking. That's the key to getting efficiency safely.
But doesn't that create a different kind of problem? If you're shifting these tasks, now you need workers with, high-level programming skills, and those can be hard to find.
That's a really important point about upskilling. But that's actually where the innovation is so clever, especially with the cobots, which we'll get to.
Okay.
The tech itself is becoming so much easier to use, to deploy and manage. It's reducing the need for a PhD in robotics and letting the existing floor staff, with some training, take on those supervisory roles.
So the technology is adapting to the people, not just forcing the people to adapt to the technology.
You got it.
This is where it gets really fascinating for me. To get the true power of this, you have to look at the sheer scope of what they can do. You hear robotics, and maybe you just picture a welding arm. But our sources listed 8 core applications that these IRs and cobots are tackling.
And when you look at those 8, you can see how they weave into basically every single step of making something. It proves they aren't just a one-trick pony.
Okay, let's break them down. First up, high-volume logistics. This seems foundational. We're talking packaging and palletizing and pick and place.
Right. And for anyone focused on efficiency, automating these simple tasks is a massive deal.
Why is that?
Throughput and consistency. Take palletizing. A robot can stack boxes with zero variation. It can optimize the pattern to fit more on a pallet, which means more in a truck. A 1% increase in stacking efficiency globally saves millions.
Wow.
And with pick-and-place, you often have vision systems that can grab delicate or weirdly shaped parts at incredible speeds, way faster and more accurately than a human can, 7 hours into a shift.
Okay, so from logistics, we move into the really demanding stuff.
Precision manufacturing.
This is where any tiny mistake is really costly.
The sources highlighted assembly and screwing, gluing and sealing, and welding and soldering. And this is where the big IRs have traditionally been king because of their speed and strength, though cobots are now getting into lighter assembly.
Let's talk about welding.
Okay, so the quality of a weld is all about consistency. The heat, the speed, the angle of the torch. Robots can hold their position down to 0.02 millimeters.
Which is what?
It's a fraction of the width of a human hair. That level of repeatability just ensures the product's integrity. It's far more reliable than doing it by hand, where fatigue naturally sets in.
And I imagine it's the same for something like gluing and sealing, right? You need that perfect, uniform bead of adhesive.
Absolutely. Especially for, say, automotive parts that need to be perfectly weatherproofed. The robot follows the exact same digital path every single time. The seal is perfect.
All right, so the last group is what you could call process improvement and support.
These are the functions that guarantee quality and keep the whole line moving.
This includes machine tending.
The unsung hero of the factory floor. Seriously.
Mm.
The robot just feeds raw material into a machine like a CNC mill and then takes the finished part out. It's monotonous, sometimes dangerous, but it's essential for keeping that expensive machinery running nonstop.
And then there's sanding and polishing. That one surprised me. It feels almost artistic, a human touch kind of job.
You'd think so, but it's all about uniform pressure. If you're polishing an airplane wing, you need the exact same force applied over the whole complex surface. That's incredibly hard for a person to do. The robot uses torque sensors to maintain that perfect pressure, guaranteeing consistency.
And finally, wrapping it all up, quality inspection. So the robot isn't just a doer.
It's a checker. Exactly.
Yeah.
You pair the robot with a high-speed 3D scanner, and it moves the sensor perfectly over a part, looking for microscopic cracks or defects.
And it does it faster and without getting distracted or tired.
Drastically reducing the chance of a faulty product ever leaving the factory. So yeah, from logistics to welding to final inspection, it's about total production control.
So what does this all mean for the future of manufacturing? The sources pointed to this huge technological shift, and they gave an example. A company like JK Collaborative Robots.
Right. And this is where the conversation really takes off.
Because the cobot is what's making all that versatility accessible.
That's it. Traditional IRs were a massive capital investment.
Yeah.
You needed huge production volumes to even think about it. The cobot it flips the economic equation on its head.
And with the JK example, the defining word isn't speed or power, it's collaboration.
Yes.
It's fascinating. They are explicitly built to work safely alongside human operators. That is a massive, massive distinction. It changes everything about how you'd even lay out a factory.
It absolutely does. And it's not magic, it's technology.
Mm-hmm.
They run at slower speeds,
Mm-hmm.
for one, but the most important thing is they have these highly sensitive force feedback systems.
Meaning if it bumps into something.
Or someone, it stops instantly.
Mm-hmm.
Or it limits its force, so you don't need the big, expensive safety guarding anymore. You can put it right next to a person at their workstation.
And that collaboration piece connects directly to how accessible they are. The source mentioned easy programming and flexible deployment. What does easy programming even look like? I'm picturing lines and lines of code.
And that complexity is exactly what kept smaller companies out. But cobots use intuitive interfaces, like on a tablet.
Hmm.
And the biggest innovation is something called lead-through.
Lead through.
You, the operator, can physically grab the robot's arm and just guide it through the motions. You show it, pick this up, move it here, turn this bolt. The robot records that path and turns it into a program.
Wait, really? So if you need to change your production line next week for a new
You
product,
should retrain the cobot in minutes or hours. You don't need to call in an external robotics engineer for 3 days of reprogramming.
That's incredible.
That flexible deployment makes automation possible for small batches. Before, you only automated if you were making 1 million of the exact same thing. Now you can do it for a run of 1,000.
So the cobot is really where it all comes together. The high-level efficiency, the safety, the ease of use. It's the precision of a big industrial robot in a safe, agile package.
And if you connect that to the big picture, it just demolishes the barrier to entry. It's the democratization of robotics.
Which raises a huge question. If manufacturers can adopt and reprogram automation this easily, what does that do for their ability to scale or react to the market?
It gives them a competitive agility that used to be reserved for the giant auto manufacturers.
This has been a true deep dive. We've seen that modern robotics covers this huge range of applications, from palletizing to precision welding and inspection.
And we established that the goal is always that powerful mix of productivity, safety, and efficiency.
Critically, the rise of the collaborative robot with examples like Jaka is all about collaboration, simple lead-through programming, and flexibility.
Which is opening the door to smaller businesses all over the world.
So if these incredibly powerful tools are now so much easier to integrate and adapt, the whole competitive landscape is shifting under our feet.
Right. And I think the provocative thought to leave you with is about the speed of innovation. If these tools, which were once only for industrial behemoths, are now accessible to small and medium businesses, what does that unleash? You should really consider how this democratization of robotics could impact your own field. Could your local competitors suddenly adopt manufacturing processes that were just out of reach a year ago? And maybe more importantly, what new, highly customized or low-volume products can now be made efficiently because that cost and complexity barrier is just gone?
A truly challenging question. Thank you for joining us for this deep dive.